We are very happy to introduce you to Geoff Preece from Position Partners Australia, one of NavVis's best partners, and he is going to explain to you key applications of NavVis technology in Australasia. So welcome, Geoff. Come on board.
Thank you. Thank you, Chiara, for that wonderful introduction. So let's get started. So, Position Partners. We are the premier provider of intelligence positioning solutions for surveying, civil works, mining, and building activities. So a little thing about us, a journey has taken us across borders and giving us a strong position in the market as one of the largest positioning solutions providers in our region. And then add to this our laser dealer networks in Australia and Southeast Asia. We have probably easily the largest footprint of any geospatial equipment provider in the world at this point in time. So we partner with world-class renowned brands to cement an envious collection of products and software to suit almost any positioning task. So a lot of those brands you'll see here over the next 3 days. Core markets. So Position Partners is committed to increasing productivity for customers in these markets and building lasting business relationships around high caliber positioning activities. So let's get to the outline of what I'm going to speak about today. First thing we'll talk about is what we have learned as a reseller of NavVis over the last year or so. So lessons learned, feedback from our customers, all of that information. And then we'll get into some detail around specific projects that have been delivered by our customers in the region using the VLX and Ivion core software. So that'll be a residential road survey, as well as a scan to BIM project completed by one of our clients in Brisbane. A colleague of mine was going to be on stage wearing the NavVis VLX, Mr. Adam Burke, who is the executive manager of all of the geospatial business in Australia. And what I've found conducting, 50, 100 demonstrations at this point in time is that people really love to engage with the VLX, particularly people who are passionate about technology. They like to try it on, they like to walk around, they like to collect data. And Adam is one of those such people. And I find that wearing the VLX attracts attention. And Adam is certainly one of those people who revels in the attention. So he's going to wear the VLX and take a bit of a stroll as I go through the presentation. So hopefully by the end of the presentation, you'll get a bit more of an idea around practical applications with the VLX and what's happened in our market. So what have we learned as a reseller and essentially as a user of a VLX is that the algorithm is genuinely robust. So I think we've processed over 70 to 100 data sets at this point, our data sets, demo data sets for customers. And we've had no failures, no issues around reprocessing. There's been no situations where we've had to send data back to NavVis. It just works. So NavVis are very clear about how the VLX is utilized. And also we as a reseller are really clear around what are the best applications for the technology. And as long as that is adhered to, the data has been really fantastic. So we've also learned that the VLX sits very comfortably in the mid-tier TLS market. So we are very open with the data captured by the VLX. So we will go out, demonstrate to customers. They will use the VLX, and typically they want to compare it to data that they have already captured with their TLS systems. So ultimately, we leave it up to the customer to decide around their parameters of that evaluation. But a lot of the time, they come to the conclusion that the VLX is is right there with their TLS products. So we've done our own evaluations of the technology. So this is a screenshot from a much larger investigation comparing the VLX to TLS data. So a cloud-to-cloud deviation analysis was performed between the TLS data and the VLX data. So this is one screenshot of a larger report, but it's a little bit hard to see, but it shows how well the VLX data fits to the TLS data. So we're looking at, 0.6 of a mil deviation, 1.6 mil deviation. There's a bit of an outlier there, 12.5 mil deviation, but I think in that case, the operator of the VLX maybe turned a little bit too quick in that room and produced a little bit of inaccuracy. And we've had very positive feedback from first movers. Surveyors or laser scanning professionals in the field, the feedback we get is that it makes their job easier. They love to use the equipment. They enjoy it. They produce work a lot faster than they would with TLS. It may attract more attention than they're used to conducting a survey, but ultimately, if it makes their job easier, they're really happy. And particularly, so surveyors in the field, they love it, but also their managers, survey managers, management of our customers, or management in our customers, they appreciate the ROI around investing in the technology. So, and it's actually been a lot faster than they would, they initially forecast. So, getting on to a couple of these projects. So the first one, in this particular case, the customer was looking for a solution to assist with a project that consisted of about 3 kilometers of linear corridor. The corridor was made up of residential road and service pipeline, and the requirement was to produce a full as-is condition survey from boundary to boundary that would be used as a reference state in a dilapidation survey. Oops. So the method of capture, in order to capture repeatable, accurate point cloud information, a comprehensive control network was measured along the corridor using a total station. And these ground control points, along with strategically placed loop closures in the operator's trajectory, ensured optimal results. And that point cloud was verified against quality control strings by a total station about every 300 meters. So just to look at one of the chunks of that data set. So this image shows loop closures and control point locations along one trajectory of the data set. And if I zoom in, you can see the loop closures there. So we have 50-meter sections, I suppose, of loop closures across a 400-meter data set. And we have 3 control point locations per loop. So that was considered as an optimal trajectory to achieve what the customer required out of the data. And if I zoom in further, you can see a little bit more detail there. But what I've found is this type of trajectory map is actually quite artistic. It looks really nice to present to customers in demonstrations. So the results, you can see line work was a result of the deliverable of the project. So the VLX point cloud was found to be more than accurate in terms of obviously accuracy and coverage for the automatic feature extraction to pull out the line work. So there's a short clip coming up to show that process. So the normal approach to this dilapidation survey would be to use a total station and a pole to capture curbs and service hatches, but using the LiDAR from the VLX provided more context, so more details, even down to the conditions of the pavement. In this image, you can actually even see ground penetrating radar marks on the road surface, and the client was able to look at the condition of the road via the high quality imagery as well. You can see service hatch locations clearly defined, and the main features of the survey. So one of the things that was important around using the VLX was that it provided a visual context to the survey. So providing a before and after view for key stakeholders once the works had been complete in the actual project. So basically making sure driveways and pavements were all back in their correct locations after the work was complete. So it provided that visual context, that story that you may not get from a traditional survey. So the point cloud on the right is without color values. So in this instance, hopefully it demonstrates or is showing the completeness of the VLX data, as opposed to TLS data where you'd get missing data, you might get some shadowing. The VLX, as you can see, produces a much richer data set. And it was actually easier for the automatic extraction, the curb line extraction to work. And this is an image of the end result. So you can see the colorized point cloud on the left. You can see the line work there on the bottom right. And then that's the full extent of the project. So 1.5 kilometers of road survey. And I believe the VLX data came within 20 mil of survey control across that entire 1.5 kilometer section. Each of those scan setups or trajectories, each data set was about an hour of collection. So the results, very important. So the customer estimated that would have taken typically 4 days with a traditional survey, total station, and GPS workflow. And they were able to capture that data you saw there, 1.5 kilometer in road, down to 4 hours with the VLX. So resulting in about an 87.5% reduction in time, which is very key. So less time on the road, reduced cost as well in terms of traffic management. So in and out quickly, very efficiently. One of the other results was obviously, as I mentioned, a more in-depth condition survey that could be used to settle any disputes once the project is handed over to the end client. In this case, it was the council. And I mentioned extraction. So the VLX data was actually used in a piece of software called Topodot. They have a booth here as well. And you can see in this video that hopefully will play. There we go. So the Topodot software using the VLX road scan data was used for the curb extraction. The comments made by Topodot was that the VLX data gave them extremely nice, crisp data with little noise. And that was, allowed them to do the extraction quite easily. All right. Project 2. So a typical scan to BIM type project conducted by a company in southeast Queensland called Bennett Bennett. So essentially, it is an internal and external survey for a proposed redevelopment of the structure in Brisbane. So what Bennett Bennett did is they feature extracted all of the surface features to produce a 12D Civil 3D model and modeled the buildings and above ground structures in Revit. So some screenshots of the data collected, the end BIM model, the imagery from the VLX, as well as the point cloud. And you can see the BIM data as a result of that project. And the results they achieved, which is pretty incredible. So the field pickup for that Revit model took an hour with the VLX, and they estimated that would have taken about 16 hours with their TLS. The field pickup for the 12D and Civil 3D detail survey, 10 hours with the VLX compared to 32 hours with TLS. And using Ivy on Cloud post-processing, they estimated that they saved themselves about 30 hours in registration processes. Some of the other benefits they achieved with the VLX is superior coverage. I already mentioned that. It was a one-person job. So no legs, no bipods, no laser scan targets. And what was very important for them, which is interesting, is the VLX produced no noise. This was a library. It was a live situation where people were in a library. The operator was able to walk through the library and not disturbing the people partaking in reading a book. What they found with the dynamic object removal filter, that it saved, obviously, processing time. They weren't manually deleting vehicles or people from the point cloud. And they estimated that it removed about 60% of those people and vehicles just using the algorithm alone. And then, yeah, obviously, cloud processing, it was a lot of data. They had a lot of data sets. Once that data was up in the cloud processing, there was all processing in parallel, and that saved them that approximate 30 hours of registration time. And that's the result. Thank you very much. Thank you for your time. Thank you, Adam, for wearing the VLX, and enjoy a good rest of INTERGEO.